All right. Oh, I didn't put the section number on there, did I? Well, that was silly. Yeah, section 5.5. All right, here we go. All right, we told our little stories, and now it's time to do this. Here we go. Shh. Doesn't seem like you're really listening to what I'm asking you to do. Is this complex numbers? Yeah, sorry. No, it's not. It's not complex numbers. And I should put an S on the end of that. Sorry. All right. So complex numbers. What in the world is a complex number? It sounds like they're just numbers that are really hard, like a really complex number. You know, when we think of complex, we think of something that's very difficult. But if you think back it's been a long time since I've had an English class. It's probably been, how many years? Probably 40 years. Probably 42, because I think my freshman year, I took the last time I ever took an English class. I think my sophomore year. I took like maybe three or four English classes in college, I guess. I don't know. But anyway, when I took grammar, do you guys even learn grammar anymore? Okay. Didn't you have like simple, compound, and complex sentences? Okay. Does a complex sentence, is it like any more difficult than a compound sentence or even a simple sentence, really? In a complex, if I remember right, you guys said you just did this? So isn't a complex, remind me, isn't it the combination of a simple, or it's two simples or something like two clauses? Is that what it is? Okay. But a complex sentence is just a combination of a couple different types of things, whether they're sentences or clauses or whatever, right? Well, a complex number is also just a combination of two different numbers, all right? Again, I'm trying to remember which class I said this. Remember we talked about imaginary, I think it's you guys. Remember we talked about imaginary numbers? And we talked about, what were the other kind of numbers? Real numbers, okay? And that's what a complex number is. It's a combination of a real number and an imaginary number. And a lot of times, they use the letter Z to represent a complex number, all right? So I'll just put a little dash and put complex number. Do you remember what they used to signify real numbers? The R, but the weird looking R. Remember that? Kind of looked like that. I don't know if you remember this or not. What whole numbers? What letter do they use for whole numbers? W. What about integers? Z? I don't think so. Did they? Wasn't it Q? What was Q? Q was rational? Okay. Yeah. I don't think Z was it Z? Yeah, look it up. I don't know. But anyway, we use Z to represent complex numbers. So let me show you what a complex number is. What did I say earlier? It's a combination between a what? A real number and an imaginary number. So here's what it is. It's A plus B I. They use Z, but they use the crazy Z, right? Like this. Okay, Z. I used to say Z when I lived in Australia. Yeah, we said Z. All right. So anyway, so there we go. So just a regular old Z is complex numbers. A crazy looking Z with that double bar looking thing is integers, correct? Okay. So anyway, this A plus BI, that's what we're looking at right there. That's a complex number. It's a combination between a real and imaginary. Which one do you think is the real number? Just the A. Okay, so that's the real part of the complex. And the B, or the BI, because they go together, that's the imaginary. All right. So the number together, now this could be a minus as well. It doesn't always have to be a plus. All right, it's plus or minus. So imaginary. All right. So that's your imaginary part. That's your real part. When you add them or subtract them from each other, the whole thing is considered to be a what? Complex number. Now, we're not going to get too much into this, but I will mention this briefly, that if you had, here's how you would graph a complex number, and it looks kind of similar to what we have graphed before, except, everybody watch, except we're not going to have we're not going to have an x-axis and a y-axis. The x-axis that we're used to would be considered your real numbers. So along the x, along the horizontal, would be considered your real numbers. Along the y, guess what? Would be the imaginary numbers. So you got reals along this way, you got imaginary this way. So if I had something like that, z equals -3 plus 2i, we can actually graph it on this coordinate system, okay? It's not a regular Cartesian coordinate system because we don't have x and y, right? This is your imaginary, I guess, coordinate system. We did. No, this is 5, 5. All right, so how would you graph this? Well, you go what? -3 on the what? Not the x-axis, but the what? The real number axis, okay? So this is the real number axis. This is the what? Imaginary axis, okay? So this would be on the real axis, and so you just count 1, 2, 3, all right? And then you do what? This is your I-axis, so what do you think you do? From here you go where? Up 2. That's it, okay? So that point right there would be found from this, okay? So that would be -3 plus 2i. Remember, it's a number. It's even though it's a combination of two different numbers, it's one number. It's one complex number, right? So that point right there is your complex number. This on the real, this on the imaginary, okay? Then they're also going to talk about this. They're going to ask you to find the absolute value. So this is a little different than the absolute value you're used to. The absolute value of a complex number. So let me show you that. Absolute value of a complex number. I took a class in college. I might have mentioned this before. I can't remember. But I took a class in college that's called complex analysis. All right? It sounds like complex. Oh, man, it's really hard. But I kind of enjoyed that class. It was one of the real upper level classes. Like in college, when you're a math major, taking calc is kind of like taking algebra in high school, right? Then after that, it gets hard, all right? So I took like calc 1, 2, and 3, and then you take these crazy classes, and to this day, some of those classes, I have no idea like what it's even used for or anything. It just gets real theoretical, a lot of proving, a lot of proofs. We didn't do any proofs in geometry. Well, we did very, very little. And but anyway, we had a class called complex analysis. And basically what it was kind of like doing not just algebra, but trig and calculus and things like that, but using what kind of numbers? Complex numbers, okay? So there's whole entire courses like this. So what does it mean to take the absolute value of a complex number? Well, here it is. If I go from that point to the origin, the length of that, okay, the length of that line right there is the absolute value of that complex number. Do you hear me? So you could say this. So a plus bi, put an absolute value symbol there. That's equal. I'm going to save that for just a second, okay? So let's take a look at this. Let's change colors. How would I find the length of that line right there that I drew? Well, you know how far you went over this way. How far did you go? Let's make that a straighter line. You went over 3, right? So I didn't put that right underneath of it, but that's good enough, I guess. And then let's just go keep it yellow. Boom. Like that. Goes off a little bit, but you get the idea. All right? So I want to find the length of that red one right there. So how far did I go over? Went over what? 3. It's -3, right? But you see what we're going to use, though, don't you? What are we going to use? That one thing you learned. Yeah. Yeah, it is. It kind of is. What is that? Pythagorean theorem. Very good. You got it. Okay. So does it really matter if I go negative or positive to find the length of that right there? No, it doesn't, because I'm going to square it anyway, aren't I? So I could put negative if I wanted to, but I'm just looking at the lengths right now. So the length of that is 3. What's the length of this one up here? It's 2. So how would I find the red one? Use the formula. Okay, so what would it be? It would be c squared equals, I'm going to write it like this. I know you guys know it as a squared plus b squared equals c squared, but it's the same thing, isn't it? All right, so we'll call this the c. A lot of times they'll call it r. Why do you think they call it r? What would the reason for that be? Because look, if that thing went all the way around like this, what would it be? It'd be the radius of the circle. Okay, that's why a lot of times they call that r. We're not going to right now, but you might see that at some point later. All right, so let's find c. What are we going to do? It doesn't matter which one's a or b, so I go what? 3 squared plus what? 2 squared. Okay, and then if I want c by itself, what do I have to do? Square root it. Agreed? All right, so let's go back to this. Remember, the absolute value. This right here, that right there is the absolute value of this. Okay? So how would I write it in a general way? Well, I would just say what? Square root of, how did I get the 3? That's the a, isn't it? And then what did I do to that a, that 3? I squared it. Plus, what? What's the 2? The 2 would be the b. What did I do to that 2? I squared it. Okay? So this right here is kind of like a little formula for the absolute value of a complex number. And how did we get this? We just used Pythagorean theorem to get that. You okay with that? So if you draw it out and look at it, you're like, oh, okay, I got a right triangle, I got 2 sides, got my 2 legs, so I just square both of them, add them up, take the square root, bang, I've got that. Let's just finish this up since we're here. What would the absolute value of that be? Be what? Square root of, that's 9 and 4, 13. So what is the absolute value of this? So here's how I could write it. They say, what is the absolute value of negative 3 plus 2i? What would it be? Just the square root of 13. Okay? So they could ask for something like that. Make sense? Let's do, that wasn't like an official example, but let's do the official example, and this would be example 1. That was just to show you what we were doing. So now, here's the example. They're going to say, graph, I'll write it down, graph. They're asking you to graph it at first just so you can kind of get used to what's going on. But I think maybe eventually they're just going to say find the absolute value. All right, so graph it and find its absolute value. All right, should be easy to graph. Would you agree? I'm going to do it real sloppy here. I'm not going to draw straight lines. Just do like that. So now this is a 1i right there, isn't it? So what's the real part? Where do I go? 4. 1, 2, 3, 4, correct? And now what about the imaginary? Where do I go? I go down 1, right? So it would be right there. So that's the graph. That point right there is your graph. It's that easy. You just go 4, negative 1. That's like baby stuff when it comes to graphing. Would you agree? Yeah. All right, now find its absolute value. So you could just use that little formula that we just did, or if you wanted to, you could make a little right triangle out of it. Okay, it's fine with me, however you want to do it. How far is this one? What's the length of that side? That's 4. What's this one? It's 1. So how do I find the absolute value of it? Meaning finding the hypotenuse, right? Finding that length right there. So what do? You just take the square root of what? 4 squared plus 1 squared. And that's 16 plus 1 is 17, square root of 17. And that's the absolute value of it. That's the absolute value. That's the absolute value. And this is the graph. And that's what they asked you to do on example 1. Make sense? Yeah. Now, the rest of it is even easier than what we just did right there. Okay? So we're going to have to learn how to do things. When you were a little kid and you first learned your numbers, what do you think the first thing a teacher taught you once you knew your numbers? How to do what with them? How to add them. Okay? Add and subtract. Good. So that's exactly what we're going to do right now. Okay? So here's example 2.
Did you try to add first or subtract?
Oh, add. Well, that's what I'm saying. Once you know your numbers and you know how to count, then after that, then you start adding and subtracting, okay? And that's what we're doing now because we're right at the beginning. This is the first time, this is the first time that you've learned about complex numbers. So now you know what they are. You know how to graph them. Of course, you're a little kid like that. You didn't think about graphing anything, all right? But now you know how to graph it. now the first thing we learn about it is how to add, and then we're going to subtract. Then after that, what do you think we're going to do? Going to multiply, and I don't think we do any division. But we at least multiply. All right, so let's do this. This is part A, and it says simplify, but if there's addition, then you add. If it's subtraction, then you subtract. Okay, that's what they're asking you to do. Very, very easy. I promise. I know I get told all the time, Mr. Hamrick, you're always saying this is really easy. Of course it's easy because you already know how to do it. I'm like, yeah, you got a point. Okay, so but this is easy. I'm telling you, this is super easy. So when you have complex numbers and you're adding them together, just like when you added like terms, remember that? It's kind of the same deal. Okay, you're just adding like terms. So you just add the reals together, and then you add the imaginaries together, and you just put them together. All right, put them right next to each other. So what are we going to add first? The 3 and the 5. What's 3 plus 5? Yep. And then we add the imaginaries. So you got a 2i and a negative 4i. That gives you minus 2i, and you're done. It's easy. It's very intuitive. You probably could have done that before I even mentioned the word complex numbers, because to you, the I would have just been a variable, correct? Yeah, it would have been no big deal. But now it's not a variable. What is it? It's a number. What number is it? Very good. It's square root of negative 1. That's what number it is. It's an imaginary number, okay? Which does exist, by the way. We talked about that yesterday. Let's do another one. I did. I created it.
Like, how does someone even create math? Like, adding makes sense.
Yeah, like how do you like create a formula and stuff?
This is just literally nonsense.
All right, here we go. Let's do this. Subtraction. So what are you going to do with that subtraction? First of all, do we really need the parentheses? Well, the second one we do, don't we? Like right here, did I need the parentheses here? Not really. All right, right here, I didn't really need the first parentheses. I definitely need the second one, because what do you have to do to that minus? Distribute it. Okay, so what do we get when we distribute it? Negative 2 minus 6i. Again, you could have done this before I ever mentioned the word complex number to you, because you would have thought that that was just a variable, and this is exactly what you would do if it was a variable. Okay, the math is. Anyway, so what do we do? 5 minus 2, 3, negative 3i minus 6i, negative 9i, and that's it. That's your answer. That's one number. What kind of number is it? It's a complex number. That's one number, okay, but it's made up of two different kinds of numbers, all right, a real and an imaginary. Let's do the next thing. So that's adding and subtracting. So what do you think we're going to do now? We're multiplying. So that's a 5i, 3 plus. So we're taking just an imaginary number, multiplying it by a complex number. The imaginary number, you could think of that as a complex as well. How could you think of that, just 5i, as a complex number? What's the real part? It's 5i, so that's the imaginary part. No, I said just the 5i. Just the 5i. What's the real part of that? No, it's with the I. The 5 is with the I. No? Look, it's a plus bi, correct? That's a complex number. Okay, so if this is 5i, yes, it would be 0 plus 5i. Okay? I thought you would see it right away. Now you see it though, don't you?
There's nothing else there, so obviously 0 would make sense.
Right. 0 plus 5i is the same as 5i, correct? But 0 plus, because it does. All right. It's on the number line. All right, here we go. What do you think? Again, at least the first part of this problem, you probably could do without me ever talking about imaginary numbers. Now, towards the end, though, you're going to have to know something about imaginary numbers to get the final answer to this. All right, so let's do it. What are we going to do? Take that 5i and do what to it? Distribute it. Distribute it. Okay, so if we multiply there, 5i times 3, what do you think? Multiply the reals, they're not reals, but multiply the coefficients or the number itself. So that's 15i. Yeah, easy. Plus, and then 5i times 2i, which would be what? 10, what? I squared. Now, if I never taught about imaginary numbers, you would have had to stop right there, and that's all you could do. All right, but now we know something about I, don't we? Remember we talked about this yesterday? What's I squared equal to? It's negative 1. That's right. Okay. Why? Because I is the square root of negative 1. If I square it, what happens? Cancels out, and it's a negative 1. Okay, so anytime you see an I squared, it's negative 1. So let's write it out. 15I, what's this? 10 times, let's just show it. Might as well, since it's the first one. 10 times negative 1, right? Because I squared is negative 1. So this is 15I. What's this going to be? Minus 10. But we don't keep it like that. Why don't we keep it like this? Because what's a complex number look like? The real first and the imaginary second, correct? So don't keep it like this. How would I write it? Negative 10 plus 15I. That's the way you need to write it. Make sense? I probably will. Because I'm telling you right now, that's how I want you to write it. And if you don't, then you're not doing what I asked. Okay? So write it like that. Any math person would write it like this. Okay? So that was part A. Let's do part B. This one's a little bit trickier, but it involves stuff that we've done before. Shouldn't be that big of a deal. It's not factoring. Foil, right. What?
Is it possible to make a new math equation?
I don't know. So let's just concentrate on this, okay? That's part of the problem. You need to focus. You're not focused. Focus on what we're doing right here. So look, this times this. It looks like a FOIL problem, doesn't it? And the first step or two is going to be just like a regular FOIL. I mean, you could look at it, it was a variable, but it's not a variable. It's actual a number, and we're going to have to do some stuff with it, all right? You're going to get an I squared, you're going to make a negative 1, and all that. So let's do it. Let's do first outside, inside, last. So first, what do you get? 8. Outside, you get plus 12i, correct? Inside, you get minus 4i. Make sure you put the sign down. And then the last, you get minus what? 6i squared, okay? So we could do a couple things here. I'm going to go 8. These are like terms, aren't they? So let's add those up. What do you get? Plus 8i. Now, eventually, you should just be able to do this in your head, but I'm going to show you the step, okay, since this is brand new. All right, so this is a minus 6. What's I squared equal to? It's negative 1. But could you do this in your head?
Yeah.
You should just be able to look at that and say, oh, that's negative 1. Negative times negative is what? Positive, and you're going to see right there you'll get the positive, okay? And let's just do it. You know that's going to be positive. What's 8 plus 6? 14. You see that? I didn't really show this step. Hopefully you see it, right? Because negative times negative is positive. 8 plus 6 is 14. What? Plus 8i, and that's how you do it. Can you add the 14 and 8 together? No, because it's an imaginary number. That's a real number. They don't go together, okay? It's all you can do. We good? Okay. Oh, man, see, I should have never done that stuff at the beginning. Shoot. I had like 10 more minutes. Let's do another one. That's what I said. If I had. I'm lamenting the fact that I wasted time at the beginning of class because I really could use it right now. All right, it says to multiply. Here we go. This one is kind of the same, but it's a little trickier than what we just finished doing. But the steps are the same. All right, here we go. Doesn't this look like a difference of 2 square problem? Remember this? A plus b times a minus b. Right? So, because that is the same as that, except one's plus, one's minus. Agreed? What did this come out to be? Without doing the whole FOIL method thing, what is that? It's a squared what? Minus b squared. So can't we do the same thing here? So we don't have to worry about the outside and inside. Let's just do the first and the last. So what am I going to get on the first? Which is 9. Now, what's my sign going to be? Minus. And now what do we do? Just multiply the last together. So let's watch. 5 times 5 is 25. Let's do the i's last. Is that all right? Square root of 2 times square root of 2 is 2. And then I times I is I squared. So that looked really complicated. It looked like it's crazy, but actually it works out pretty nice. So watch. What do I get? 9. So 25 times 2 is 50. I'm not going to put a sign just yet. What's I squared? Negative 1. Minus negative 1. What's that going to be? Positive. And what is that? Look at that. So I took something with square roots and i's in it, and it came out just to be a regular, real number. Okay? All right. There was, yeah, let me give you this. So section 5.5, it's page 208. We didn't quite finish, but I think I gave you plenty to be able to do all of these. I gave you 36, but all right, that's what I was thinking. All right, even though on the lesson plans it says to do 1 to 36, I'll take it easy on you and just have you do the odds. 1 to 35 odds. Okay? Sure, go ahead.